Hey, Denver Black with SOILCRAFT here. I'm joined with my compadre, Trey and we're out here in a potato field that we've been managing this year. And we just wanted to take a minute to discuss what we've been doing and what we're seeing. So I've kind of been doing a series of videos out here in this. And the main issue we're addressing in this field has been sodium. They irrigate with groundwater, and sodium accumulates and appreciates in these fields, and right, we know sodium has a positive charge, and it tends to compete against things like calcium and potassium and ammonium and manganese. Any of those plus charge, it can compete or antagonize against and basically hold them out of the plant. And so absolutely the plants need sodium, but at a small amount, and in these particular fields it's been in excess. So the main way to do that, or the main way we've been working at that, has been with biology. It's been with our Vermicast T applied evenly throughout the growing season, at least 6 applications throughout the growing season. And in this field in particular, we've been doing 2 different iterations of that. We've been doing it in two different ways to measure and see if one is superior to the other, or just how they stack up. And so far what we're seeing has been promising. We've been monitoring it with sap samples, soil samples, and then what you probably can't see is there's a soil moisture and a soil EC, electrical conductivity, in 3 different places on this field, measuring both of our trials as well as a control. So we're out here today digging potatoes to see how it looks, and we're pleased to see, that ours is bigger than the control.
Just kidding.
Just kidding. This isn't the same mound, but it has been interesting to see. I mean, the potatoes are doing very well. It's very promising. It's definitely too soon to make any conclusions to see how it's doing compared to the control. And one of the most important things will be storability. How well these potatoes hold out in storage without rotting. But the field you see us standing in has had no fungicides, no insecticides, no nematicides. It was fumigated last fall, but only because we hadn't started working with the grower yet. This coming fall, on the next year's trials, we'll be using Vermicast T, minerals, nutrition, soil food in replacement of fumigation. And
the growers mentioned this morning that they were pretty much shocked that we had no fungicide applications, no insect problems to speak of. Nothing's above threshold that needs dealt with.
Yeah, no.
And they were pleasantly surprised.
No disease to speak of, no nasty molds. And when I asked him, when he says, "Well, we're going to be applying this in our field, so what do you think? What do you guys want to do?" And I said, "Well, if you're okay, comfortable with it, let's just keep using biology." But I said, what reasons are you treating it for? What is this fungicide, treating? Well, this, that, the other, I mean, 6, 7, 8 things. Well, what insects? Well, 5, 6, 7, 8 insects okay. And so, not that they're always present or would be, but a little prophylaxis there. And, our fields have been full of bugs. No question, they've been full of bugs. But they're predators. I mean, you go out here and you see ladybugs and lacewings, baby praying mantises, spiders. I mean, there are just tons of predators. We see primary degraders when you dig into the leaf litter. The soils here smell amazing. I mean, that is probably the biggest difference. We were talking about the difference between the conventional and where we're treating with biology.
You can
smell.
Totally smell the difference.
I mean, the chemical one smells kind of stagnant.
Not much of an odor, or more of a sour.
Yeah.
Kind of a sour
odor. Yeah, so anyways, we're excited about what we're seeing. We continue to see that when we put biology first, when we always remember that these are living systems with living soils in an ecosystem, and when we put biology first, quality follows. So
one of the largest things that we've seen with these EC meters, Denver was pointing out yesterday and this morning, was that same field treated with biology and minerals, carbon, etc., has an EC, I think, what was it, 0.28, and the control side, it's just normal conventional, was 0.44. So almost.
And that's the latest. The one
almost
a week prior was exactly.
And that's probably one of the growers, from what I heard this morning, is one of their biggest issues, is
Yep.
sodium coming out of the wells, coming out of the water, and continuing just to build up in these fields, and that causes a plethora of issues and disease. So if we're able to grow a crop and reduce the EC and reduce the sodium all at the same time, that's huge. That's
Yeah.
exciting.
Are you surprised?
No,
You
it's just
know,
exciting.
that's the coolest thing, is that whether it's cherries, hops, onions, wheat, grass, beans, garlic, you name it. Like, when we treat the crops as living systems with biology and nutrition, they grow well. They're happy, they're healthy, and what they produce is healthy. So we're actually going to run these potatoes through a battery of tests as well to see about mineral nutritional content. Trent did that with his cherries that he grew biologically this year compared to conventional cherries, and found 4 or 5 different minerals that, what, 40% higher?
Everything was from 20 to 40% higher.
Yeah, so we're excited to see if it's the same in potatoes, a food thought of mostly just for calories. So stay tuned, and we'll continue with more videos to follow up on, again, on yield, on quality, and on storability. Thanks very much.